Right. Hello, everyone. So welcome to the afternoon session. This is going to be about an end user discussion. We have had 3 invites today, and present are Piotr Rydlichowski from the Supercomputing Networking Center in Poznań. He's responsible for the Network and Technological Division. And he's also participating in the OpenQKD activities and the QUAPITAL projects and many other things. We will hear a short introduction from him as well. And Dimitris Sivridis from the University of Athens. He's at the Department of Informatics and Telecommunications, and also the head of the Optical Communications and Photonic Technologies Lab. Unfortunately, Benedek Kovacs is not able to be here with us today, or he might be able to join later, but let's go on. And I would like to ask Piotr to introduce himself in the beginning, please.
Yeah, thank you, Aurel, for the kind introduction and invitation. Yes, I'm working at the Poznań Supercomputing and Networking Center in Poland. We are located in Poznań. We are one of the HPC centers, the 5 HPC centers in Poland. Also, we manage and maintain the metro area network in Poznań. We connect a lot of different users, activities, and projects. And more or less, we are also owner and operator of the Polish Research and Education Network Pioneer. So we have an almost 9,000 kilometers of fibers and infrastructure in Poland and in Europe. And PSNC is the owner and operator of this network. So we are owner of the full infrastructure. So the fibers, the transmission equipment, and all the also services that are connected with that. And myself, I'm working in the optical projects also since few years, specifically with quantum communication and also with the quantum computing. Yeah, thank you.
Okay, great, thank you. And thanks for accepting the invitation here. It was a very short notice, so I really appreciate that you could make it. So Dimitris, please.
Yeah, thank you as well for the invitation. I think it's a nice opportunity to know each other and see what's going on in Eastern Europe. So from our side, we're working on photonics since about almost 40 years, a bit less. And the lab is one of the oldest in Greece working on photonics, participated in all these different, activities in optical communications, optical components, networks, and so on, in the framework of, European projects and also other bilateral activities with industry. Currently, we have strong interest in investing in the quantum area. So we've started related activities the last 2 to 3 years, something like that, 3 years, I would say. And we have now just received the equipment, 2 pairs of Alice and Bobs from Toshiba. And we set up a test bed here in the university, some tens of kilometers, where we are going to test different variants of the QKD. So in the project of the OpenQKD, we mainly together with the Greek authorities, public authorities actually, in order to help them understand how this technology could be useful for them.
All right, great. Thank you for the introduction, and I'm really happy to have someone in the program from Greece. We're trying to make this this event as inclusive as possible to show researchers and other actors from Eastern Europe. And let's move on. Start with the questions. So you have introduced yourself, and clearly your original background is not in quantum, but at one point your organization with your lead is now turning more and focusing on quantum solutions, and this is what I would like to ask. If Dimitris, you can expand more on other projects that you might have or other visions, and
yeah. Okay, actually, the idea here, I mean, we're now focusing on, as I said, on quantum, and the idea here is to see whether we can try to find solutions to overcome the difficulties or the, the problems that nowadays appear in the QKD application. So this means that we're working on authentication processes for the Alice and Go. So we're trying to include technologies related or based on physical and clonable functions in order to authenticate the two parties in the QKD communication, which is quite crucial nowadays. And it's one of the weak points, actually, of the QKD. And also to see what can be done in terms of the trusted nodes, because in the plan, in the Greek, scenario of implementing quantum technologies, we intend to use quite long installed fiber, and then in that case, there will be needed a lot of trusted nodes in between. So we're working on that topic as well.
Okay, great, thank you. Piotr, you have not mentioned the activities of the Poznań Supercomputing Center in Quantum. Can you summarize them?
Yes.
Even expand, we have time.
Yes, so maybe just I will present just one slide to show the activities. It would be, I think it would be easier. Yeah, you should see the slide. So basically we are focused on all aspects connected with the high performance computing. So data repositories, digital libraries, next generation networks, everything which is connected with grids, clouds, new media, visualization technologies, knowledge platform, future internet technologies and special applications, cybersecurity, and quantum communication and computing. So we are the IBM Quantum Network Hub. So we do connect a lot of users who wish to use the IBM Q services and infrastructure. But myself, I'm mostly focused on the quantum communication and, to be honest, mainly on QKD. So within the OpenQKD project, we are one of the test beds. We have several use cases which we are running under the test beds. Just recently, we finished almost 10-month-long use case with colleagues from Ostrava and Cessnet in Czech Republic. So we were running the cross-border and between the cross-network, I would say, QKD service between our infrastructures. And as a typical operator, maybe we do connect to a lot of infrastructure and services within the Europe. So in CERN, in Amsterdam, and within the quantum communication, as I mentioned, we are in part of the OpenQKD, QUAPITAL, and also we are running national projects. We are participant of national project called National Laboratory for Photonics and Quantum Technologies. And under this project, we are working on the intercity long distance QKD link between the research groups. And also we try to focus a little bit also on general quantum communication. So not only on the QKD, but also a step further. So the general quantum communication. And so from my experience, I can support Dimitri's thoughts about the issues that we have. But from my side, the most important part is simply, at the moment, integration of the QKD technology and authorization and certification. Yeah, these are really crucial elements right now that's really can stop the further progress if we do not have here the common agreement.
Okay, that's very exciting, and so these are the current focus. And how do you imagine the position of the superconducting center in the future in Poland? Or
yeah, so we are network operator in the HPC center. So we see us as a hub that, on one side, we want to use the services for our own purposes. So together with the QKD providers and the optical transport equipment providers, we run activities and projects to further advance the technology as itself. But we have to provide, and actually this is the most important part, so the user that works with us. So on the one side, the end users are we as HPC Center, but on the other side, as a research and education network, we have a lot of users and in academic community and the government and all the, let's say, public institutions. So they need to see the clear benefits and possibilities, how to integrate, how to use, what are the advantages and disadvantages for the, at the moment, QKD, but also the quantum computing services. So we run a number of projects and that show some real applications and benefits. They are not maybe in all cases a game changer, of course, taking into account the current state, but they show a clear, I think, the path and progress and possibilities that we have for both of these technologies to be used and how they can be adopted. And also on the other side, the education aspect. So we try to encourage education in this matter. Yeah, that would be my update on that.
yeah, education is also. I also personally think that education is very important, and it is also critical for the end users. We're going to turn to this question later. It connects to what you just said. So the end users can be. It might be a bit artificial, but for the purposes of this present panel, we can classify end users into two categories. So the academic institutions are themselves end users, but also there are the private sector, which is also an end user, and you are both from the academic community. I'm also from the academic community. I'm even a theoretical physicist, and however, you're both in contact with the private enterprises. I looked at Dimitri's bio, and he has a very extensive experience in this. So what I would like to ask here is with this is we might be more familiar with the academic, but that you can address that first. So so how do quantum get a priority within how gets emphasis within your organization, and how do you see that with your partners? What is the decision making that leads to existing companies that might be the network operators or any other? Now we're mainly talking about communication. So what do you see in there? How they get involved in quantum? So Dimitris, if you can.
I think the most important parameter which we have to mention and take into account is the price nowadays of the components and the equipment. And broadness of application, because we have worked quite closely with a lot of Greek authorities, in principle being interested in adopting such technologies, because cybersecurity is obviously critical and becomes more and more critical. And the problem is that there are quite a few obstacles, I would say, in terms of the compatibility with existing infrastructure, the integration into the legacy systems, also the cost itself, because imagine that we are talking about a cost of a couple of hundreds of thousands of euros per pair, which is really very high. And this is high even for, rich research centers. I mean, where they want to invest in order to produce new knowledge, or probably help with the private sector to generate new products. But in any case, this is not easy to deal with. I mean, such high cost. Take into account that we are talking just about 2 nodes. And then we have again the problem of distributing the keys, and then you have all the problems of authentication, of security, or at all these levels, and so on. So I think this is important. It's important to build an ecosystem around this quantum heart, let's say, or the physical security layer. An ecosystem which will be at similar security level to that of the heart of the quantum system itself. So that's the main problem. Another problem is, the requirement for dark fiber installation, which is not. Okay, there are always the possibility of coexistence with legacy systems, the same fiber, but it's not trivial. I mean, there are again limitations in this respect. Quite a few things. So I think that although there is a lot of progress, nobody could imagine 10 years ago that we would have now 10 key systems that we can have them and try to use them. In practice, still there is a lot to be done in order to have them, broadly accepted and used at the different layers of the network and so on.
I see. So basically, what your message is that when it comes to cybersecurity, then the organizations don't need to be convinced of the purpose of using quantum technologies. They are mainly just looking at the expenses, and they need to make that kind of decision based on their budget, right?
Well, they find it very, very attractive in the sense that, the quantum technologies promise the ultimate security, the unconditional security. And this is indeed attractive. On the other side,
they are easily convinced.
Yes, because, the arguments are quite straightforward. On the other side, the limitation is related to the scalability of the system. I mean, okay, they could adopt it for certain links, for certain very crucial, communication systems and so on. But the problem is to have it, somehow broadly installed and scaled in the network. So I think this is the big bet nowadays. To see how can we move forward in that direction. So, in our case in Greece, for example, we have engaged 3 telescopes, one in the northern Greece, the other one central Greece, and the other one in southern Greece. And then we're going to use this QKD through satellites. And then we can have 3 different clusters, big clusters, terrestrial clusters, which will be interconnected through the telescopes and have, coverage at the area of Greece and at a later stage, of course, in Europe.
All right. This is already something that you're looking forward in terms of the EuroQCI, or is this
exactly
a separate project?
Mm-hmm.
Okay, I see. So I have the same question from Piotr. your
Yes.
partners?
Yeah, so I agree with Dimitri's thoughts. Yeah, exactly. In our case, I would say that we saw that in many areas we could, using our own experience and infrastructure that we have, we really can support and help different colleagues to further develop these technologies, QKD and quantum communication, especially from the application point of view, management and integration point of view, because we have to remember, as Dimitris mentioned, that so it's not, I would say, it's easy to convince to show the benefits, but the commercial user needs to have a clear view regarding the advantages, disadvantages, and integration possibilities, because they will never use this as the only solution. They want to integrate and fit this. I have in mind the QKD solutions into existing environment that they have. So they really need to know how to integrate it, and they treat it as an additional element of their infrastructure and how they treat it. But of course, apart from the purely security point of view, they also have many other motivation and reasons how they want to pursue. Of course, some of them are not known because this is internal, let's say, strategy and business of the of the company regarding security. But in majority, I think they just want to use it and use it on top of and together with all the solutions that they already have to fit in the existing environment that they have. So that's why I think it is really important to have in mind the integration and, of course, the certification aspects of this technology. Because without that, of course, it's not possible to use it in operational way and in a secure way in operational environment network. It will not make any sense.
Yeah, I can relate to that. Regarding this, so you have also mentioned, you both mentioned that that in the end, all these technologies need to be integrated. So the compatibility and the integration plays an important role. And you're both. I'm also actually involved. That's how I contacted you. We're all involved in the OpenQKD project, in testbed projects. And so my question is, how much impact do these OpenQKD projects have in helping companies adopt this technology, or maybe it has the opposite effect, that they just run away when they see what complications this brings. So Dimitris, I can ask you to begin.
I think it was useful. I mean, at least in Greece, there was not a lot of activity on that topic. I mean, until the last 2-3 years, and this was really a useful activity because the people get familiarized with the technology, found that there are certain use cases that can be where the quantum technologies can be useful, and they're considering that quite seriously. I mean, we're discussing with people from the energy sector. I mean, critical infrastructures, things like that, and they find it useful. They are considering such solutions. Also, the governmental, parties are, of course, very interested in that. But as I said, for very specific cases, not in a broad installation base. But I think that this OpenQKD was really useful because the people realized what's going on. It's a bit for someone, even being a scientist, it's not easy to get in touch with such technologies and understand the basics and all these things. So it was a useful activity.
Okay. Can you mention what was the focus of the government regarding this OpenQKD or adopting QKD, or is this confidential?
Well, I cannot say much actually, but what I can say is that there are already preparation of investments in that direction. And I think that we'll see things also happening in the near future in Greece and installing further, in a further basis all these systems. I think it was really very, very useful.
Oh, okay. So I will leave it that way.
Yeah.
And but it's really exciting. So waiting for such thing. And so how is it in Poland?
Yes. So in my
and you mentioned also the collaboration with the Czech Republic. So this
yes.
is actually a very interesting part. Yeah. If you
Yes,
can.
the OpenQKD, in my view, it is really important project because it really showed that the equipment, of course, the equipment that we have is not certified and not it's still under development, but it showed that it is working in the conditions that we wanted to work and use, and it is scalable. We can scale the solutions, and most importantly, we have a lot of use cases. So if you can see at the OpenQKD web page, there are really a lot of different use cases, and also through the open calls, we had 2 open calls for the project, and we've attracted a really high number of very, very interesting use cases and partners. So I think it was really huge benefit for the community to show different, very, very different use cases and ideas, how it can be used and potentially scaled in the QCI, because we need to remember that OpenQKD it's kind of pilot, so it was before the QCI call, so it showed and laid the grounds for the QCI activities. So in that terms, it's very important. And one of the use cases that we've implemented was the cross-border QKD connection with the Technical University with Ostrava, also in collaboration with the CESNET colleagues from the Czech Academic Network, Research Network. So all together we've set up the connection. It was running almost over 10 months, stable without any problems. And we've set up HPC service, which was computing service, kind of example, of course, of SEPI that was using this encrypted traffic. But the real benefit from my point of view was to show the challenges that you have to take into account when you want to connect such service between the different providers and networks. There are some considerations and issues that you need to have, and the vision how you want to set up such service. So it's connected with purely implementation and integration. So, and how the operators work and how they want to use it. So from this perspective, I think it was really interesting. And yeah, I think the OpenQKD also showed how in the next step in the QCI activities, the use cases can be scaled, changed, and further developed.
I would agree, and also, put it in a more important basis, the problem of certification, especially when we're talking about, as Piotr said, when we're talking about public authorities and security services and all these things.
Yeah, and also if we look at who is developing the equipment, QKD equipment, we need to show, and we need to know that the research institutions, they may not have the full knowledge about how to certify and how to know the whole process to certify the equipment and use it for this service. So this is something also very important for the providers and developers of the equipment.
And this is a major obstacle for adopting this technology, at least in the sector, because we had a lot of discussions with the people there, and they have their own systems. I mean, you know, these NATO-approved crypto systems and all these things. And they say, okay, I believe you, it's a really a good technology. I mean, it's reliable and so on, but I need to have, you know, the stamp. I need to have a certification. How can I use them without this certification? So it's extremely important either to certify them as standalone machines or to provide a kind of certification in collaboration, in cooperation with the existing security technologies, the crypto systems that are now used in all these authorities. And this is something we're working on with these guys to see how can we proceed in this direction. But this is extremely important. I agree with Piotr on that.
Yeah, within the OpenQKD, we also have the workshops regarding the colleagues from AIT, the coordinator of OpenQKD. They've organized workshops regarding standardization and certification, and also on the website there are documents. So everyone who's interested can follow the latest developments regarding these activities.
Yeah, and as I remember, there was a recent call for an FPA on QKD certification. Do you think that it's enough to wait until that FPA turns into something useful, or it's already necessary to move on with the certification now?
Yeah, the works are ongoing, so it will just simply complement what is being done within the ETSI, the focus group in ITU. So I think we need a little bit more coordination between the different standardization organizations and to coordinate this work. I'm not sure, Dimitris, what's your view?
Yes, I definitely agree. But so it's extremely urgent, actually, to see something in the near future as soon as possible. It's really important. Otherwise, there's no luck with systems because they have also would say some, you know, some disadvantages that should be overcome, having at least this kind of certification and then allowing them to be used broadly.
Okay, so that's so unfortunately we're only discussing here quantum communication. There are of course many other aspects of quantum technologies that could be used, but when we talk about certification and standardization, then in this security aspect, this is all amplified, but I believe that this is something that extends over to other applications of quantum technologies. For example, if we look at sensing, I mean, that's definitely one of the things where you would need something.
Yes, exactly. It will take time, and it's really not not easy. It will be a challenge, exactly.
But it sounds very exciting. Now I have let's move on to the next question. So the other one is the next one is again about your experience. So you have there's a certain level of complexity of getting these systems work within a corporate environment, and when you deal at different levels of these organizations, at what sort of difficulties you see at each level when you work and talk to the people in particular. Maybe Piotr, maybe you can be the first one.
Yeah, thanks. So I think the first approach, and I think it's not only connected with the QKD but also with the quantum computing, is to explain exactly how it's working, the current state of development. So it's really important to show the current state, what is possible, what is not possible, what is planned. So the first step, difficult step, is to explain the current state of the art, I would say. The costs, of course, Dimitri said it is still expensive. So we have to wait and see for the integrated maybe solutions if they will be more cost effective, and the integration possibilities. So in our case, it was quite easy because we own the network. So all the telecommunication infrastructure, the fibers, the nodes, the services, everything is owned by us. So for me, it's quite easy to set up tests and run experiments. But for other colleagues who have to rent for some time or some part of the network, it can be a challenging, to do this. So that's why these test beds and the OpenQKD approach to set up test beds, so everyone can join and take benefit from these activities, it's useful. There is also a web under OpenQKD. We also set up virtual test bed, so it shows the equipment, the use cases, and the statistics of the operation, so everyone can check and see the status.
I think that even though there is quite well developed all these devices, there is still lack of maturity. I don't know what have you seen in your experiments, but we've tried to see how these devices, these systems will behave in actually in real conditions. And it seems that, for example, give you an example where we had quite a few problems. When you have a significant difference in the path between the service channel and the quantum channel, then in that case, it's really difficult for the system to synchronize and have reliable operation. And you cannot always have the paths be, identical or almost identical. So this is one of the requirements, for example, of a network operator or something. You're not have, a dark fiber and the service channel exactly with the same physical length. Or, losses, attenuation, all sorts of things. So there is still a lot of room for development and improvement in the maturity of even this, basic technology, the point-to-point communication.
Yeah, and also exactly, and also the input from the simply from the operator point of view, the typical procedures and how the equipment is used. It's also very valuable, and indeed we collaborate with the providers, and they really value the update that we have from the test beds and for the equipment, and we try to test it all the way. And the issues, as Dimitri said, with the differences, and also we test the co-propagation system. So with we have a use cases which use the dedicated fibers for the quantum channel, but also we have the equipment under the project which is capable of multiplexing the data traffic with the quantum channel, of course with some limitations. It's always a trade-off, and you have to take into account when you design the use case and the service that you want to test. Yeah, but it's still very valuable to test it.
From the point of view of operator, as you said, we are now currently experimenting with systems operating in the O-band. So in principle, there is the possibility to have coexistence without a lot of problems. But even in that case, when you want to bypass the nodes and to avoid any connection with the active components of the network, then you add losses. And then you reduce, the overall fiber span, or the position, the distance between transmitter and receiver. So, okay, there are always possibilities to overcome some problems, but then you face other problems and so on. So there is quite a lot of work to be done in order to.
Yeah. Also, it's interesting to see how the equipment is working at the edge, on the edge of its performance. So it's declared the performance.
Mm-hmm.
So you know what you can expect and how the service degrades, and what measure can you take, and how do you correlate with, for example, we can see the correlation with the environment conditions at the position of the sun, which is lighting at the equipment, of course, because it's we have single photon detectors. So yeah, it's interesting to see that also.
Yeah. So what I gather is that that there are many. So it's not a mature technology. There are many difficulties, many unexpected things, and nevertheless, you're trying to show that you can provide a service, which means that has to be constant monitoring. There has to be people who are able to mitigate whatever problems arise. Plus, also there's also the question of deployment. So how does it how is it with the availability of experts who can perform these tasks? What do you see, and what would you recommend, or what would you foresee also in this area, Dimitris?
Well, at the level of automation, the automation level of the current system is relatively high. And if one wants to go deeper into the system itself, it will be rather difficult, and it's not allowed by the manufacturer. So if you want to do modifications to the system, I don't think it's possible. So the manufacturer has to intervene with that. So at the level that these systems operate nowadays, it's relatively easy to support them by someone that has a basic training. The problem is that sometimes they need intervention from the manufacturer to readjust things to. Otherwise, if they're operating according to the specs and having, optimized the environment, the operation environment, then I don't think there is a lot of need for highly specialized personnel to support them.
And can you imagine that on a network of the scale of the EuroQCI, the manufacturers will have the capacity to monitor and maintain all these?
This is a challenge for them to develop much improved, much more, mature technology. So the need for such intervention should be as low as possible. I mean, this is a major challenge for the manufacturers. So I think that, I don't know, especially if we take into account, the satellite connections, which is a big unknown, especially when we're talking about, geostationary satellites, or even, different setups that will be tested there. I'm not sure that it will be a turnkey solution, There will always be the need for someone, or, specialists that will take care of the systems and so on. But at least at the minimum stage, we need to have something operating at a certain level, and then to build upon that to have something, closer to the global quantum network, as close as possible anyway.
Okay, thank you. We're slowly coming to the end of the session. So, Piotr, if you have any comments on that, but I understood that you're basically solving everything in-house, right?
Yeah, so we try to exactly extend our knowledge, and together with the colleagues from different the partners from the OpenQKD, we try to develop to solve the issues, and I think it's working very well. We try to collaborate as much as possible, and yeah, the skills, yeah, it is the education part is important, and yeah, but it's a separate topic. Yeah, separate.
It is definitely a separate one. So we're almost out of time. So I would like to ask you if you have any last message or your favorite quote, perhaps, as a closing of this discussion. Piotr.
Yes. So from my side, really, I think the advancement maturity is in most of the elements are there, but we need to focus right now on the standardization certification aspects to progress much further, and of course the further use cases, applications.
Dimitris?
Yeah, I agree with Piotr, and also to find, solutions for the integration of the systems to the legacy infrastructure of the network. So this is quite important as well.
So compatibility with the existing what is there.
Exactly.
Okay, great. So thank you very much. It was a real pleasure to have you both of you here, and for the rest of the audience, there is going to be a break, and then we'll soon resume with the rest of the program. Thank you.
Thank you. Thank you for inviting. Thank you.
Thank you. Also, all the best.
Bye.
Bye.